Hello everyone, you're welcome to this tutorial session on Math with Ella. Today we are going to be solving the June 2024 question on the theory of quadratics. This was question 1, Roman 2, and it reads, if the roots of a quadratic equation x squared plus k plus 1x plus k is equal to 0 are alpha and beta, find the values of the real constant k for which alpha is equal to 2 beta. So, solution. First thing is to write out the equation that we had, the quadratic x squared plus k plus 1x plus k is equal to 0. We've been given that the roots are alpha and beta. We're given a condition on the root alpha equal to beta. So before we go ahead, we have to recall that whenever we are given a quadratic, like the general form of a quadratic, which is x squared plus bx plus c, then the sum of roots is given as negative b on a, where b is the coefficient of the x term and a is the coefficient of the x squared term, and the product of roots is c over a, where c is the constant term and a, of course, is the coefficient of the x squared term. So we are going to apply this here. First thing is to find the sum of roots. Sum of roots in this case, we said the roots were alpha and beta. So the sum of roots will be alpha plus beta, which will be negative b on a. B is the coefficient of the x term, that will be negative k plus 1 on a. A is 1, the coefficient of the x squared term. And we have a condition on this root. With the condition is that alpha is equal to 2 beta. So replacing alpha by 2 beta as is indicated in the question, we are going to have 2 beta plus beta is equal to negative k plus 1. And 3 beta is equal to negative k plus 1. Beta is equal to negative k plus 1 on 3. Let us call this equation 1. Now the next thing will be to find the product of roots. POR, product of roots. Again, the roots are alpha, beta. Product of roots, C on A. C is the constant term k, and A is the coefficient of x squared 1. So, again, going by the condition that was imposed in the question, alpha equals 2 beta. So, replacing this alpha with 2 beta, we have 2 beta times beta equal to k. So 2 beta squared is equal to k, and beta squared is equal to k on 2. But from equation 1, we've had an expression from beta. So substituting equation 1 into equation 2, let us call this equation 2. So we take this value of this expression which we've gotten for beta and we substitute into this equation 2, and then we simplify. Doing that, we are going to obtain negative k plus 1, all this squared. Negative, of course, is on 3. So negative k plus 1 on 3, all of that squared, that's beta squared, will be equal to k on 2. So we substituted equation 1 into equation 2. And then we have to simplify. So simplifying this, we are going to have k squared plus 2k plus 1, all of this on 9 is equal to k on 2, and cross multiply, we have 2k squared plus 4k plus 2 is equal to 9k. So we have now a quadratic in terms of k, and then we have to rearrange and then solve for k. So we have 2k squared plus 4k minus 9k plus 2 is equal to 0. We simply bring the 9k to the left hand side so that we are left with 0. On the right hand side, we obtain 2k minus 5k plus 2 is equal to 0. We need to solve this quadratic. You can solve it using any of the methods, quadratic formula, factorization, and even graphical, but I'm going to use the factorization method. So I'm going to look for factors of 4, which when added will give us negative 5. And those factors, negative 4 and negative 1. So factors of 4, which one added will give us negative 5, are negative 4 and negative 1. So we have 2k squared minus 4k minus k plus 2 is equal to 0. So if you negative 4k minus k gives us negative 5k. So we factor out 2k here. We'll be left with k minus 2. And here we factor out negative 1. We're left with k minus 2 equals 0. So we have 2k minus 1 into k minus 2 is equal to 0. Therefore, either 2k minus 1 equals 0, implying that k is equal to a half, or k minus 2 equals 0, implying that k is equal to 2. So those are the values of the constant k that satisfy that equation following the condition of the root that was imposed, or following the condition that was imposed on the root, that is alpha being equal to 2 beta. So that's it for this question, and I hope you've understood. Kindly follow our page for more of this, and until I come your way again, remain blessed.